In this unit, we're going to explore what I believe is the most fundamental concept in software engineering, understanding why code complexity sits at the epicenter of every software problem you'll ever encounter. By the end of this unit, you'll understand why complexity is the root of all software evil, how it compounds to destroy even well intentioned projects, and most importantly, what can you do about it? Let me start with a bold claim that might surprise you. Of all the different types of complexity we deal with in software, business rules, architecture decisions, infrastructure concerns, deployment pipelines, it's code complexity that matters the most. Not because the others aren't important, but because code complexity amplifies every other problem and sits at the critical intersection where all these concerns must actually be implemented. Now, before we dive into why code complexity is so crucial, let's establish the different levels where complexity exists in software systems. At the top level, we have business complexity. This includes domain rules, user workflows, regulatory requirements, and the inherent complexity of the problems we're trying to solve. If you're building a healthcare system, you're going to deal with complex medical workflows. If you're building a financial system, you'll have complex regulatory requirements. This complexity is largely unavoidable. It comes from the real world. Then we have architectural complexity. This covers service boundaries, data flow patterns, integration strategies, and how different components of your system interact. Should you use microservices or a monolith? How do you handle eventual consistency? Where do you put caching layers? These are important decisions that affect your system scalability and maintainability. Infrastructure complexity deals with deployment pipelines, monitoring systems, scaling strategies, and operational concerns. How do you deploy safely? How do you monitor system health? How do you scale when traffic increases? This complexity has grown enormously with cloud computing and DevOps practices. Finally, at the bottom of this hierarchy, we have code complexity. This includes control flow, state management, abstractions, naming, and actual structure of the code that implements everything else. Here's a crucial insight that many developers miss. Code complexity sits at the epicenter of all of these concerns. It's where the rubber meets the road, where abstract architectural decisions become concrete implementations, where business rules transform into executable instructions. Now, let me explain why code complexity deserves special attention through five key insights that fundamentally changed how I think about software engineering. Number one, it's a point of execution. All those beautiful architecture diagrams, elegant domain models, and sophisticated infrastructure designs mean absolutely nothing if the code that implements them is incomprehensible. The CPU doesn't execute your architectural sites, it executes your code. Let me show you what I mean. This method signature alone should terrify you. We have meaningless parameter names, a generic map for context, Boolean flags, integer bit flags, and variable arguments. The actual business logic is buried under layers of conditional complexity that no human can safely reason about. When your elegant authentication service looks like this in the code, no amount of beautiful documentation can save your system's reliability. The bugs live in the code, not in the diagram. Second, it dictates change velocity. When you need to add a feature or fix a bug, You don't modify architecture slides or documentation, you modify code. The complexity of that code directly determines how fast and safely you can make changes. Now, consider these two approaches to the same functionality. The first method is straightforward. If I need to add email validation, I know exactly where it goes. If I need to add audit logging, I can see where to insert it. The change path is clear. Now, contrast this with the second implementation. In this version, a simple email update becomes a minefield. You need to understand all the conditional branches, figure out which validation path applies in your case, ensure you don't break legacy compatibility, and trace through intertwined logic that might have side effects you don't expect. I've seen teams where a simple four-line change required a 2 week investigation because the code is so tangled that nobody can predict the consequences of modifications. Third, bugs live in the code. Software defects ultimately stem from mistaken instructions in the code. Complex control flow, implicit state dependencies, and duplicated logic multiply the surface area where errors can hide. Here's a realistic example of how bugs hide in complex code. Can you spot the bug? The comment tells you that there's a discount being applied twice. But in this nested conditional structure, it's not immediately obvious where or why. The bug might only surface when you have a premium, non expired order over $100 that already has a discount and belongs to a VIP customer. That's a very specific combination that might not be caught in testing. Research consistently shows that cyclomatic complexity, essentially the number of decision points in your code, correlates strongly with defect density. Every additional branch point roughly doubles the chance of introducing a bug because it doubles the number of execution paths you need to test and to reason about. Fourth, cost compounds over time. Every extra branch, flag, or special case in your code creates tech debt that compounds over time. What seems like a small shortcut today becomes an enormous maintenance burden tomorrow. Let me show you how this progression typically happens. It starts off simple and clean, one responsibility, clear intent, easy to understand and modify. 6 months later, somebody needs urgent notifications. Still manageable, but we've introduced our first conditional branch and our first Boolean parameter that changes behavior. 1 year later, the requirements have grown. Now we have multiple conditional branches, null checks, fallback logic, string truncation, and a growing parameter list. Each addition seemed reasonable in isolation, but collectively they've created a maintenance nightmare. This is the compound interest of complexity. Each hack makes the next hack easier to justify and harder to avoid. Soon, you're paying interest on tech debt with each single change you make. Now, here's a fundamental constraint that many developers don't fully appreciate. It's not CPU power, memory capacity, or network speed that limits our software systems. It's human working memory and our ability to reason about code. Cognitive science research shows that humans can hold about 7 plus minus 2 concepts in their working memory at once. This is called Miller's Law and it applies directly to software development. When your code requires holding more concepts in your head than this limit allows, understanding and modifying it becomes exponentially more difficult. Now, look at this example that exceeds cognitive capacity. Look at just the parameter list. There are already more concepts there than most people can hold in working memory simultaneously. When you add the local variables, conditional logic, and method calls, you've created something that exceeds human cognitive capacity. When code exceeds cognitive limits, several problems emerge. Developers start relying heavily on external tools and documentation just to understand what the code does. Tribal knowledge becomes critical. Only certain people understand certain parts of the system, creating single points of failure. Changes become risky guesswork rather than confident modifications. Bugs multiply exponentially because nobody can trace all the interactions. New team members struggle to become productive because the learning curve is too steep. Now, complex code creates a vicious cycle that can destroy software projects. Let me walk you through the 5 stages of this death spiral so that you can recognize and interrupt it before it becomes fatal. Stage 1 is the initial complexity. This occurs when shortcuts are taken under pressure. Maybe there's a tight deadline, so someone takes a quick fix instead of doing it right. Copy paste programming becomes common because it's faster than creating proper abstractions. Technical debt starts accumulating. Velocity degradation happens when those shortcuts start affecting productivity. Changes take longer to implement because developers spend more time understanding existing code than writing new code. There's growing fear of breaking existing functionality, so changes become more conservative and require more testing. Quality erosion sets in when bugs become harder to isolate and fix because they're hidden in complex interactions. Testing becomes incomplete and unreliable because there are too many edge cases to cover. Technical debt accumulates faster than it can be paid down, creating a growing burden. Team dysfunction emerges when senior developers start leaving for simpler code bases where they can be more productive. New hires struggle to become productive quickly. Knowledge becomes concentrated in just a few people, creating dangerous dependencies. Project crisis is the final stage where feature velocity approaches zero. Every bug fix attempt introduces new bugs. The only viable option becomes rewriting major portions of the system, which is expensive and risky. The only way to break the spiral is to actively manage complexity from day one. You can't wait until you have time to clean things up later. By then, the complexity has compounded beyond manageable levels. Now, managing complexity isn't about following specific design patterns or frameworks, though those can help. It's about relentlessly applying one core principle in everything you do. Make the complex simple, not the simple complex. This principle manifests in three key practices. First, create clear abstractions that hide complexity behind well designed interfaces that reveal intent. Now, here's what I mean. This interface tells you everything you need to know to use it. You give it a payment request and you get back a payment result. All the complexity of handling different payment providers, retry logic, fraud detection, and error handling is hidden behind this clean interface. Now, compare this to the complexity leaking mess which is there. This interface forces every caller to understand and configure retry behaviors, timeouts, fallback providers, and audit contexts. The complexity has leaked out of the implementation and infected every usage site. Second, practice disciplined naming that reduces cognitive load. Choose names that make code self documenting. Now, when I read this method, I immediately understand what I do, uh, what it does, the first one, what data it operates on, and what the results will be. The names carry the meaning clearly. Now, contrast this with the second one. This method name tells me nothing useful. What does process mean? What does the flag control? What are the different modes? What options are valid? I would have to read the implementation to understand anything about this method's purpose. Third, practice relentless refactoring to continuously pay down complexity debt. Now, if you look at the first conditional, it has five separate conditions added together. To understand when the discount applies, I need to hold all five conditions in my head simultaneously and understand their relationships. Now, in the second implementation, the main logic is clear. If the user qualifies for a premium discount, apply it. You can take the complex conditions and isolate it in a method with a descriptive name. Now I can understand the main flow without getting lost in the details. Now, learning to spot complexity problems before they become critical is essential. Let me share the warning signs I watch for at different levels. At the code level, watch for methods longer than one screen, roughly 30 lines. When a method is too long to see entirely at once, it's probably doing too much. Cyclomatic complexity above 10 is another red flag. That means too many decision points in a single piece of code. More than three levels of nesting creates code that's hard to follow. Boolean parameters that change behavior are often signs of methods trying to do multiple things. Classes with more than seven public methods might be taking on too many responsibilities. Now, note these are all, you know, what I would call things you need to look out. They're not hard and fast rules, but these are generally signs. At a team level, phrases like only Sarah understands this module indicates dangerous knowledge concentration. When changes require extensive testing, even for small features, it suggests the code is fragile and interconnected in unexpected ways. If new bugs appear when fixing old ones, it means the code has hidden dependencies. When feature estimates become increasingly inaccurate, it's often because complexity is making changes unpredictable. Code reviews that turn into architecture debates suggest that code structure isn't expressing intent clearly. At the business level, watch out for time to market slowing down despite hiring more developers. This is Brooks Law in action. We're adding people to a late software projects makes it later. Customer complaints about software reliability often trace back to complex code that harbors bugs. When competition moves faster with smaller teams, it suggests they have simpler, more maintainable code. When technical decisions start driving business decisions instead of the reverse, complexity has begun controlling the organization. So let me leave you with the big ideas that you should fundamentally change how you think about software development. Code complexity sits at the epicenter of all software problems. It's not just one concern among many, it's the amplifier that makes every other problem worse and the choke point that limits how fast you can adapt to changing requirements. Human cognition is the limiting factor in software development, designed for the 7 plus minus 2 rule. Keep the number of concepts someone needs to hold in their head to understand your code within human working memory limits. Complexity compounds exponentially. Small shortcuts and quick fixes create tech debt that grows over time. The interest on this debt is paid in slower development velocity, more bugs, and decreased team productivity. Simplicity is a choice that requires discipline and intention. It doesn't happen by accident. You have to actively fight complexity at every step. Now, shift that I want you to make is this. Stop thinking we can clean this up later when we have time. Start thinking complexity is a debt that I pay interest on every day. Now, there never is a good time to clean up complex code. The pressure to deliver features never goes away. The only sustainable approach is to manage complexity as you go, making each piece of code slightly simpler and clearer than you found. The business impact of this approach is substantial. Lower complexity leads to faster feature delivery because changes are easier to make safely. Simpler code results in fewer production bugs because there are fewer places for errors to hide. Clear abstractions enable easier onboarding because new team members can understand the system more quickly. Manageable complexity enables sustainable growth because the code base doesn't become a bottleneck as the organization scales. Now that you understand why code complexity is the root problem, the rest of this unit will give you specific techniques to combat it. We'll explore Boolean blindness, how simple true false values can hide complex meaning and create subtle bugs. We'll examine stringly type code, what happens when strings carry critical information in unsafe ways. We'll study method call protocols, how to encode valid sequences of operations in the type system, and quite a few others. I've listed just a few of them over here. Each lesson will build on this foundation. Complexity is the enemy, simplicity is the goal. Every technique we'll cover is ultimately about making complex things simple rather than making simple things